For our third session, this is geometric distribution. So, geometric distribution involves series of Bernoulli trials pa din. So, this is almost the same as your binomial distribution, except that instead of a fixed number of trials, trials are conducted until a success is obtained. So, unlike the previous session wherein tatanungin tayo like in 18 samples of water tests, ilan dito, what's the probability that 2 of this will contain a pollutant, just like that. So, ibig sabihin doon sa examples na yon meron na tayong bilang ng samples. Okay? And in that number of samples, gusto lang nating malaman what is the probability that a certain particular success will happen. Pero dito, iba. Dito, we're not we have an open-ended number of trials. Ibig sabihin, pwede lang tayong tanungin like, ilan yung samples na kailangan nating makuha hanggang sa magkaroon tayo ng success. Like halimbawa tinotoss natin yung coin, for example, this is a binomial trial or a Bernoulli experiment. Tossing a coin is a Bernoulli experiment. So when you toss a coin, and the idea here is to get ahead. Kaso nagte-tail yung outcome natin. Ang tinatanong sa atin is how many tosses or what is the probability for a certain particular success to happen with this number of toss. So, kailangan makuha natin, kung parang ang mangyayari dito is, pwedeng tail, tapos sa pang-5 pa mangyayari si head. Okay, ang tinatanong sa atin is, what's the probability na the first success will happen in a certain number of trials. Okay, so, in a series of Bernoulli trials, let the random variable x denote the number of trials until the first success. Okay. Sa binomial distribution, yung x natin doon or yung ating binomial random variable doon, yun yung number of success occurring in the sample. Okay. Occurring from the number of trials. Dito, ang x natin dito represents the number of trials na kailangan nating gawin hanggang sa makuha natin yung success natin. Therefore, x here will be known as your geometric random variable and its probability mass function is 1 minus p. So, ito yung representation ng failure natin. Failure raised to x minus 1. Kasi halimbawa nga yung example natin kanina ng tossing a coin, di ba yun ay tail, head. Okay, so, if there are 5, kumbaga parang ang hahanapin sa atin is if we're looking for the probability that your success will happen after 5 trials, di ba 5 trials yan? Dito pa lang sa ika-5 trial mangyayari yung success natin. Therefore, etong 4 na t na to, this will be represented by this exponent x minus 1, where x represents your trial now. So, in 5 trials, minus 1, 4 na trial muna na failure. Kaya you have your probability of failure here, multiplied by that 1 success we're waiting for. So, that would be 1 minus p raised to x minus 1 times probability of p or the probability of success. Now, let's have an illustration. Okay, so p again is greater than 0 but less than 1. So, it's in between 0 and 1. And x will get integral values of 1, 2, 3, and so on. Okay, so, example. The probability that a bit transmitted through a digital transmission channel is received in error is 0.1. So, the probability that a bit is in error, that's equivalent to 0.1. Okay. Assume the transmissions are independent, keyword, and let the random variable x denote the number of bits transmitted until the first error. Ito yung mahalagang indication that we are under geometric distribution. Okay, so, ang problema dito sa problem na to, na dahil problem na nga siya, is that it did not specify to us the number of trials na kailangan natin. So, if I'm going to show you the solution for this, I'll give you the probability mass function instead. So, that would be the probability of the number of trials until the first error occurs is simply equivalent to 1 minus p, so that would be 0.90 raised to x minus 1 multiplied by 0.10. Okay, ito yung magiging sagot ko. But if we're being asked, like for example, what is the probability that in 5 trials, makakuha tayo ng isang error on the 5th. Ibig sabihin, on the 5th, magkakaroon ng error. Thus, Parang ang mangyayari dyan is, you have 4 okay bits, 4 good bits, and then the 5th bit to be in error. So, ang magiging solution natin dito would be 0.90 raised to 5 minus 1. So, ibig sabihin, 4 yung nag-fail natin. Or, apat yung okay na bits multiplied by yung panglimang bit natin na erroneous. So, getting our calculator to show you the answer, that would be 0.90 raised to 4. And then multiply that by 0.10. And gives an answer of 0.65, 0.0656. So that's 0.0656, 6.56% chance. Okay, so pwede tayong tanungin sa problem na to ng kahit ilan. Ano nga, pwedeng, what is the probability that on the first bit transmitted erroneous na siya agad? Ibig sabihin, probability of x equal to 1 yun. Okay. And if this happens, ibig sabihin, you'll get here 0.9 raised to 0. Diba? Kasi 1 minus 1. And times 0.10. So, you have 0.10. Ibig sabihin, the probability that on the first bit, erroneous na siya agad, that simply gives you this probability of 10%. Okay. Next. So, for a certain manufacturing process, it is known that on the average, 1 in every 100 items is defective. It gives us an idea that the probability of a defective is simply 0.01, 1 in every 100 items, or simply 1 over 100. Okay, so what is the probability that the 5th item inspected is the first defective item found? So yun, the phrasing or the wordings of the question already suggests to you that we are looking for the probability of the random variable being equal to the number of trials we need to do until the first success is in the experiment is obtained. Okay, so ang mangyayari ngayon dito is, if we're going to solve this will be equivalent to the probability of x equivalent to 5, diba? Kasi yung 5th item daw yung first success natin. So that gives us 1 minus p, or 0.99, okay, raised to 4. That's 5 minus 1 multiplied by 0.01. So, our answer will be equivalent to 0.99 raised to 4 multiplied by 0.01. So, we get a probability equivalent to 0.0096, or simply 0.96%, di ba? In percentages, ganyan yung probability na magkakaroon tayong defective item in the first 5 items that we took. Okay? At a busy time, a telephone exchange is very near capacity, so callers have difficulty placing their calls. It may be of interest to know the number of attempts necessary in order to make a connection. Suppose that we let P be equivalent to 0.5 be the probability of a connection during a busy time. So, ibig sabihin, ito yung chance na kapag tumawag ka on a busy time, makakakonect ka, your call will go through. We are interested in knowing the probability that 5 attempts are necessary for a successful call. So, ganun ulit, the probability of x equal to 5. The probability of x equal to 5, we are talking about successful calls. And to get a successful call on a busy connection, you get a probability of success of 0.05. So, it gives us 0.95, diba? 1 minus 0.05 raised to 4. Ibig sabihin, sa ikalima pa tayo magkakaroon ng successful connection multiplied by 0.05. Okay? And that gives an answer of, let's take our calculate, 0.95 raised to 4 multiplied by 0.05. So, it gives us an answer of 0.0407, or simply 4.07% chance of having your call go through or successful. Okay? So, the mean and variance of a random variable following a geometric distribution are, yan, for the mean or the expected value, that's simply 1 over the probability of success. Okay? For the variance naman, you have your failure. Diba ito? 1 minus P all over the square of the probability of success. So, example ulit. So, the probability that a bit transmitted through a digital transmission channel received in error is 0.1. Okay, so, the probability, ito ulit, paulit-ulit itong example na to. The probability of bit in error is equivalent to 0.1. Assume the transmissions are independent events and let the random variable x denote the number of bits transmitted until the first error. Find the mean number of transmissions until the first error. So for the mean, di ba ang solution lang naman natin dito for the mean, which is the expected value. This is simply 1 all over the probability of getting an error. And here, ito yon yung probability of getting an error natin. So you have here 1 divide 0.1. So it means you get 10 errors on the average. Sorry. 10, what's that? 10 bits transmitted on the average. 10 bits transmitted until the first error. So, ibig sabihin, on the average, you have to have at least 10, or the first erroneous bit will happen on the 10th bit transmitted.